Hello. In this example, we have a graph that's been given to us. It says the graph below shows the graph of some function. Determine the intervals over which the function is increasing, decreasing, or remaining constant. Okay, this is something that a lot of people get confused on that's actually a relatively simple concept once you understand what's happening here. Now, we want to figure out when is it increasing, when is it decreasing, and when is it constant. Let me use just two different colors here. So I'm going to use increasing will be blue, decreasing will be green, and constant will be this purplish color. Okay, I'm going to start out with the increasing. What we mean by increasing is that as you're going from left to right, you always go from left to right. So increasing means you're going up from left to right. So that's increasing. If we're going down from left to right, notice I'm going down towards the right. That means that we are decreasing. And if we're actually flat, neither increasing nor decreasing, that of course would be constant. And what we're talking about here is we're always looking for the x values for my answer. Now, the y values, in other words, what the graph looks like, is what's going to determine is it increasing, decreasing, or constant. But what my solution, or excuse me, my answer is going to be a whole bunch of intervals. Now, looking at this graph, I want to figure out when is this graph actually increasing from left to right. If you need to think of having a ruler go across the page. So if I took that ruler and went this direction, where is it that going left to right, where is this function moving upwards? Now ignore that and ignore that. Now we'll come back to those, but that confuses people. So just look at this area. This is notice that it's going down from left to right. That's a problem. That means that it's decreasing. Here, notice that we're going from here and it's going actually upwards. Now it's not a straight line, but that doesn't matter. It's still going up from left to right. And at this point, it changes again. Instead of going up from left to right, it's neither increasing nor decreasing, which means it's constant. Therefore, here are your intervals. Let's look at the increasing. Now it's increasing between here to here. But remember, I'm looking for my x values, not my y values. Okay, so that means that we're actually increasing in this interval right here from 1 to 3. So your increasing is from 1 to 3. You're going to be tempted to use square brackets here, but you really shouldn't because those endpoints aren't actually increasing or decreasing. Now let's look at the decreasing. It's the same idea. We're going left to right just like this, but notice that this time if we're going down like we are here, that's actually decreasing. This was increasing and this is neither increasing nor decreasing, which means it's constant. So the left side over here is actually the decreasing. Again, we want to look at the x values, but what we should notice is that this arrow here means we're actually going this way and this way and this way, but don't be confused to think that that's increasing. Remember to go left to right. That's actually going down from left to right. But on the x-axis, which way is this going? On the x-axis, this arrow is pointing towards the left. So that means that everything over here from 1 to, just call this negative infinity, all of that is the decreasing interval. Therefore, we start out always left to right, which means we start out with negative infinity, and we go until we hit 1. And notice that that's not even part of the function because it's an open circle. That's what we call a jump discontinuity. So it's negative infinity to 1. Now, of course, we need to look at the constant. That will be the last one. And notice that since this keeps going this direction, that means that everything from here on to infinity is going to be the constant interval. Again, we're looking at the x values, so we're starting with 3 and going to the right. So it is 3 to infinity.